Hello all, welcome to my channel. I'm starting a new series of videos which will be where we will be discussing a few of the Spark things. So in my previous videos, I have discussed a lot about the 5 challenges of Spark, namely shuffle, spill, skew, serialization, storage. So in the new video series that we are doing, we will be going through some of the solutions which are there, which help us in understanding those challenges, and this video is the first installment of that particular video series. So let's get started. So one thing is that before we find out what is the issue with our Spark application, first we have to, uh, sorry, to fix the issues, we have to first find the problem which is there. And to do that, basically what we do is a, we can go through the Spark web UI and see what is going on. I have a different video as well. In earlier videos, I have discussed this how we can leverage the Spark web UI to go through and see what is going on and what are the issues, like which stage is running slow, which stage is causing issues, which join strategies are being used, is there any skew or not. So there is an well-defined video in which discusses this thing in the web UI. But that web UI and there are the challenges are mentioned in here. Like if you see, these are the challenges videos that is already there. So you can go ahead and watch if you have not seen. So now comes the part that, let's say we know our job, we went through the UI, web UI, and try to see what is wrong in there. But it is difficult to exactly pinpoint the issue in the web server unless you have very uh, expertise, like if you have managed at least uh, many jobs in Spark, and then you know by intuition that okay, this might be wrong, this might be wrong, and looking at the data in the web UI, you are able to infer some of the changes which needs to be done. But what if I told you that there is a process, there is an even simpler solution to this? So you can simply go ahead to an UI and get all the issues that are being faced by your application in one shot. You don't have to look anywhere else. That's the only place you go. And that's where this video comes into picture. And this video, I will talk about a plugin, which is an open source plugin called DataFlint, and this helps us in the problem finding of the Spark job itself. So in this video we will go ahead and see what DataFlint is and how we can leverage it uh, to make our jobs easier. So let's get started on this. So in this video we will see how we can set up DataFlint in our local Spark job. But before we go ahead, so see what we will get out of this DataFlint. This, if you see here, it says writing small partition files. This is a warning. This is for a particular job. We will get these kinds of insight that okay, you are writing some small partition files. For example, here is another warning which is for the same thing, and writing to HDFS. So it will tell us what is the issue going on with our application or the job that we are running. So and let me just walk you through the this which says what is the DataFlint and uh, some intro about it. So DataFlint is an end-to-end actionable observability platform focused on Apache Spark. It identifies the alerts and identifies and alerts on the performance bottlenecks in real time. So it gives the cluster status, SQL query execution, visualization, and performance heat maps that is available. Then it also provides us with resource utilization metrics, performance alerts, like actionable recommendation. So this is the very much important thing, that it provides the recommendation which can be acted upon. So we don't have to look through the web UI to find out what we should be doing. It will give the recommendation straight in one particular UI itself. It has Apache Iceberg integration and optimization suggestions there as well. And the visualization is way better than what simpler web UI gives us. For example, if you see, cluster time also, for example, if we are using EMR, which is elastic map reduced in AWS. Or let's say if we are using any other clusters as well, it will say what is the idle time for the cluster, what is the memory usage, how many executors, how many SQL queries, what is the duration of the time, what is then how much spill to disk is happening, how much shuffle write, how much shuffle read, how many wasted resources, how many task error rate. So all those things are available in single, not in the single pane. For example, these are from the summary page. This we have from the resources page. So there are different places where this things is, but it is very intuitive and what you call very easy to understand. So let's see how we can set up this platform on our environment. So what this is available as a jar. So we can download this jar and put it in our home directory, and then Spark's home directory, and then we have to pass a flag saying that okay, we want to use this plugin so that it is available. What I will show you here is that we will first create a Spark cluster with Docker container, and then we will run it using Docker Compose, and then we will set it up the other setups that we want to do, and we'll see how we do that. So what I have done is I have used an Amazon Linux S3 as a host. We will launch EC2 with 16 cores and 128 GB of memory. Also, since we want to open Spark history UI, we will be inbound rule of this should be allowed, or if you are using any private, then you will have to create a proxy as well. So what I did, I launched an EC2 instance. On that particular instance, I did an update. These are all Linux housekeeping stuff that we do till here. So what I did is I updated my you can follow along this video, like you can just copy paste and run this. Like first you launch EC2 instance with this configuration, then you run these commands, and this is available as a blog, so you can just copy paste from there. So what I did is I updated, I installed Docker Compose, and then I also downloaded the jar, which is for the Spark Flint that I will be using. And this is from repo, DataFlint Maven repo. So I downloaded that jar. Now what we will do is we will create 5 containers, one for Spark master, one for Spark history server, and 3 Spark workers. And the folder structure is like this. So we will have Spark local. So under data, I will keep a file that will be used in reading the file by Spark job. Configurations, the actual app, which is the word count, word counter writer, and app. There are 3 apps that we will be using, showing in this video. And requirements.txt, this is where if we have to install anything, we keep that. Then the Docker file, then there is a make file .env.spark and entry point sh. So env.spark will have some environment variable related to Spark. Make file is to just uh, run everything in one go, like creating the image and following it, building the process and everything. Entry point sh is where the Spark application will start. So the content of the entries.sh file is this, like we just define that, okay, what is that, if it is an Spark workload is equal to master, then we start the master processes, and if it is for worker, so we tell that, okay, start this worker, but connect to this Spark master, which is where the master is running. And then uh, master worker, based on that it starts, and once it is if it is an history server, then we say okay, start the history server. So this is just an argument that we say that okay, the same one entry point is available for all. And the default cons, we must mention where the Spark master points to, for what is the event log directory. This is for the history server event log. We enable first, we then give the event log directory. This is where Spark events will be stored, and this will be the log directory of history server. And then Spark plugins, although this is commented out, but you can put this uncomment as well. This simply says that we don't have to pass this flag whenever we are running a Spark submit. If we put it in here, it will be available by default. But just to say, in production systems, you will definitely want to make this available on all the jobs which are supported. And requirement.txt, what are the things that we are installing? So we are installing IPython, we have pandas, PyArrow, NumPy, PySpark, PySpark, grpcio, grpc status, Google API command. These are for uh, Spark connector. That's what this is needed for. And we will create. So now once we have this thing, we create a Docker file for our Spark job, the Spark workload, and basically we are using Python because we will be using PySpark. So this is a normal Docker file that is used for any of the Spark applications. The only thing that we are adding here is so we have a Python base image on which we install few things. These are needed for certain purposes, like for example sudo curl. Curl is needed because we will be downloading tar, vim, unzip. So these are all utils. And because we are using Spark 3.5, we want to install OpenJDK 11, not at 8.1. So those are just creating the base image ready. Then we have some Spark configurations like where is Spark home, where is Spark Hadoop home, and then we download the Spark binaries, Hadoop binaries, and then unzip it, and then remove the zip files, whatever. And when this we untar everything in opt Spark directory. Then using that, because this is just one more thing, this is a multi-stage build. So was first we have this base build done. So we have installed everything and we have downloaded the Spark, put it into opt Spark, and then we say that okay, from this Spark base, this one, we start a new layer called PySpark. In that we install few more things, whatever is there in the requirement or txt that we saw, that we install. And then after that we make the home directory, master environment variables, and everything we configure. We also copy the default comps and the jar that we had downloaded for DataFlint. We also copy that into the Spark home jars directory. So this is, and once it is done, we make this executable bin directory, the entry point. We copy the entry point, we run the entry point. Sorry, we change the execution mode of that file from, we make it basically this entry point as to be an executable, and then we start this Docker. When this Docker starts, this will be the first command that will run, which is entry.point.sh, and that will start the process. It can be for master worker or history server, depending upon which is there. So this is the Docker file. Then we have the Docker compose file that we write. So we will create three services, mainly three, but we can have others as well. So three services which are there is Spark Master, which will run the Spark driver program. Then we will have Spark History Server, which will run our History Web UI, and we will run Spark Workers, which will run the executors, and nothing else. This volume is just for this Spark log is getting mounted to see the logs. Then makefile. So makefile we will have certain commands like build, make. So we have Docker Compose up, down, and some things, right? So we just have an shortcut for that, which build will Docker Compose build all the Docker files. Up will run will make Docker. Well, run is an alias for Docker Compose up, and down is for Docker Compose down, and stop is for Docker Compose up, and submit is how we submit a job. So Docker exec into the Spark driver, and then Spark submit, run this master plan, and then deploy mode client. And in the app, we have the app directory, app file that we want to use. So this is something which we can use as an utility. And the app that we have, PySpark app, is a simple find, which simply says that we will be doing a word count example with io.print plugin. This plugin will be used, and we will read that file. We will do some splitting of the column, count the words, and this is just a simple PySpark application that we will run and see how it goes. So once we have done these things, once we have this setup ready, we have the Docker file, we have everything, and when we, let's say we say Docker compose up, or let's say this one Docker compose run. So sorry, not Docker compose, make file run, and this will, what it will do, it will first bring down anything that is there, then it will say Docker compose up, and it will create three workers, Spark workers. Now what will happen when we go to the, once this just is running, it will launch a Spark application, and app finishes, we will open the Spark history server. And the reason we are using history server is because once the app finishes, we can still see. If we use the live web UI, that time we will not be able to see the application, so applications history. So history server will give that. So if we open the history server, generally we will have only these tabs like jobs, stages, storage, environment, executors, SQL data frame. We will not have this extra tab, but because we have added a plugin, DataFlint plugin, this DataFlint will also come into picture. And see how things will be. So this will be the UI that will be shown when we click on the DataFlint tab. So it will have a summary, it will have, so these are the different tabs: summary, resources, configuration, alerts, and final Flint assistant. So the status is of the cluster, then we have summary about the cluster itself or a particular job, and then if we go to resources, it will say the cluster resources, how many unknown and everything. Configuration, it will also list down the configuration, alerts if it is generated. And so if you see if you click on alerts, something like this will be there. Sorry, here wasted course too high. So it says that we are running an executor, or we are running a job where we have too many executors, and the 93% of those 99% of the cores are just getting wasted. So these kind of recommendations will have. uh, Before we go to some other recommendation, let's see the architecture of how Flint works. So uh, this is how Spark environment is decided. Like it has a Spark driver, history server, and Spark executors. So they send. So history server is compatible with this DataFlint components. So Spark driver loads the data Flint plugin. Executors report the metrics to the data plugin, and history server, uh, which when we have Flint web UI, so history server will get an extra tab. And how it does it? Data Flint Spark plugin will register the Spark listeners, process the events. They power it from the Data Flint store. It will have Data Flint store has two, like it Data Flint API pages, whatever is powered by this Data Flint store. And DataFlint UI points to either the DataFlint API pages or the alerts pages. So DataFlint store feeds the alert to the alert reducers, and then they will identify any issues and then send it to the DataFlint UI. So this is on the project layout wise. And the UI components, if you see, DataFlint Spark plugin collects the data from DataFlint store, and DataFlint store provides data to the DataFlint API endpoints, and this is a Spark API service, so it has API HTTP request which goes to the DataFlint API endpoints, and it has a Redux store. It has its own UI components, which is there in the DataFlint UI. So yeah, this is from the UI point of view. It's something that's just for understanding. You can understand the flow, but you don't have to know. If you want to develop or build something on top of it, you should know how the flow works. But in general, to use DataFlint, we don't need this. And DataFront Planet have 5 different tabs, like status shows the real-time status of the Spark application. Summary provides an overview of SQL queries and their performance. Resources displays the resource utilization metrics. Configuration shows the Spark configurations, and alerts which list down the performance issues that are there. So if we have any performance optimization issues like underutilization of core memory resources, so these things, like it also has shuffle, read, write, output, and sizes, everything. So this will be like, so if you see the summary has data. So here see in I intentionally ran few applications which had certain issues. So one of the issues, it says that executor memory is over provisioned. So it says that max executor memory usage is only 51% of the allocated memory. So this way you see how it is giving helpful insights to us, is that it is telling us that, okay, what is the issue? Not the issue, but also kind of a solution. So it says that the suggestion is decrease the executor memory provisioning by changing the Spark executor memory configuration to 1.22 G. So what was happening is that we created, for this job, I created executor with 2 GB of memory, and at the peak it was only using 1 point, I think 1.2, 1 point or around 1 GB it was utilizing. And hence the suggestion came that, okay, if we run our Spark executor with only, let's say, 1.2 GB, it would have been sufficient. We don't have to run with, let's say, 2 GB per se. So this is, I mean, because this was small, it is 1 GB, 2 GB, but it can be, let's say, if you see in percentage wise, let's say if you are running a executor with 32 GB and the max utilization is not that high, so in that case, you can reduce it and you will get certainly claim resources in the cluster. So this is one. For example, it also says that wasted cores are too high. So 91.64% of the cores were wasted. So it calculates based on the vcore units time, vcore seconds, and then decides, okay, how much of there was a wastage. So we can reduce the number of cores as well. Then it says that there is a long filter condition. So in one of the filters which was running in the job had a filter which was very long. Filter condition was very long, so it is not that much suitable for job. It will run into issues. So what it says, it uh, that we can reduce, try to convert your filter condition to a join statement by creating a df of your filter condition and in a join. So this is providing the insights like what we can do to fix the issues, right? So that is very important. Then there was one more uh, which is something similar, but in here the condition length is 15882, and in this case it is 3920. So there are two different places where we can fix the issues. We will see what the issue is, how we can reduce that in other videos. So in this one, let's for example, under the alerts tab, we have the recommendations that are related is large data broadcast, large filter conditions, partition skew, large number of small tasks, memory over provisioning, under provisioning, and then if it is Apache Iceberg is being used, if there is inefficiency in that also, it will list down that. And when we click on the stage time summary tab, opens a new summary which will have data flow. So here, if you see, the condition was like this: or ID is equal to 196, or ID is equal to 1997, or ID is equal to 1998. The reason this is happening is I think I had added an in clause that uh, that was checking in multiple values. So that's why this condition became very large. So this is what is long filter condition is, and then we can reduce it by doing a join. Uh, so it lists information on the for the following: join, sort, select, repartition, and other stuff as well. So if you here see, if we have something like, so in one of the cases, my job had R-like condition where the regex was being used. So this is something which is not the right way to do things, and hence there is a warning, and then we can see that, okay, if we optimize that, our job will run faster, or it will run with more what you call efficient cost utilizations as well. One good thing about this DataFlint is that DataFlint supports Data Fusion Comet, Photon, and NVIDIA Rapids as well. So if we are running with these, we still be able to get all these information that is there. And the reason this is important is because in our upcoming videos, we will see how Data Fusion Comet helps us with some of the Spark challenges that we have, or Photon in Databricks. So in those cases, because if we are using that, we can still use DataFlint to find out the issues. And platform compatibility, so there are two different modes. One is DataFlint real time, and the other one is DataFlint history server. So history server supports everything like local, standalone, Kubernetes, and EMR versions, but Dataproc, SD Insights, or Databricks is not supported. But in DataFlint runtime, everything real time, everything is supported. So we can just have this configured in everywhere and use it. So this was it for our first video in this series. We will have other videos in this series which will be listing down the solutions that we have for the different challenges of Spark. For example, we will have solution which specifically handles shuffle. We will have uh, a video which specifically handles uh, which handles shuffle as well as spill and skew kind of scenarios, or it also removes the issues related to Java related memory overhead and stuff like that. So keep tuned in. Do watch out this channel, and you will get videos of all those things. So there is a line of videos that will be coming, around 6 to 7 videos. So yeah, if you like this, do subscribe and have a nice day. Thank you.